Hi guys, it's Mrs. Hunt. Today we are going to go over some exponent properties. Now before we get started, remember that an exponent tells you how many times something is being multiplied by itself. Okay, we're going to learn a bunch of different rules for this, but I think the easiest way to do it is write it out instead of using the rules. So x to the third power means I have x multiplied by itself 3 times. So I'm going to write that out as x, x, x. Then I see my dot to represent multiplying. And then I have x to the fourth power. That means I have x multiplied by itself 4 times. So we're going to expand it, which means get rid of the exponents by writing it out. And then we're going to put it all back together and see how many total x's we have. I have 1, 2, 3, 4, 5, 6, 7 total x's multiplied together. So that's going to be x to the 7th power. The reason it's not 7x is because, remember, coefficients tell you how many times you're adding something together, and here we're multiplying. So my exponent should be 7. Okay, the next one, I have a squared, which means I have a multiplied by itself twice. Then I have a to the fourth, which means I have 4 a's multiplied. So I'm expanding it to get rid of my exponents, and then I'm going to recount it up and see how many I have in all. So I have a total of 6 a's, which is a to the 6th power. So this is just simplifying your expressions. This is a simpler way of saying a squared times a to the fourth. They are equivalent to each other. Okay, now we're going to do one that has coefficients. So for this one, exponents only affect what it is directly touching. Okay, so this 2 does not have an exponent written. We're not going to say it doesn't have an exponent at all, it just doesn't have an exponent written. It has an understood exponent of 1. So I'm going to write it once. And then my a is what has the exponent of 3. So I'm going to write my a 3 times. Now again, this 3 doesn't have an exponent. So I only write it once. And then this a has an exponent of 2. So I'm going to write it twice. So these are just coefficients, so we're multiplying them together. 2 times 3 is 6. Then we're going to count up how many a's we have. 1, 2, 3, 4, 5. We have a total of 5 a's. So that's a to the 5th power. Okay, now the next one, we have coefficients again. This 3 does not have an exponent though, so I'm only going to write it once. And then my a has an exponent of 4, so I'm going to write my a out 4 times. Then this negative 4 doesn't have an exponent, so I write it once. And then this a has an exponent of 6, so I'm going to write a 6 times. Multiply your coefficients together. 3 times negative 4 is negative 12. And then we're going to count up how many total a's we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 a's. A to the 10th power. So you might have noticed when we start, I had x to the 3rd, x to the 4th, which gave me x to the 7th. Well, 3 plus 4 is 7. Over here, I had a to the 2nd times a to the 4th. 2 plus 4 is 6. I got a to the 6th. Here, I had a to the 3rd, a to the 2nd. So that becomes a to the 5th. 3 plus 2 gives me 5. Here, I have a to the 4th times a to the 6th. That gave me a to the 10th. 4 plus 6 is 10. So that is where our rule is coming from. It says when multiplying numbers with the same base, that's what's being raised to the exponent, you keep the base and add the exponents. So that's what this is saying right here. keep the base, add the exponents. Notice how when I multiplied my x to the third with my x to the fourth, my x stayed an x. Then we just added the exponents. So that's called your product of powers property. Okay, now we're going to move on to another one. This one now has two exponents. We have parentheses raised to the second power. So since I have parentheses raised to the second power, just like before, your exponent tells you how many times you write something out. So I'm going to write my parentheses out twice. Well, I still have exponents, so I'm not done expanding. So the way you're going to write out your 2 to the 4th power means you have 2 4 times. But then I also need to expand my second parenthesis, which also says 2 to the 4th power. So that also means 2 4 times. So I'm done expanding it because I have no more exponents. So now I'm going to put it all back together. I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So that's 2 to the 8th power. That's a correct answer, or you can actually state what 2 to the 8th power is, which is 256. Either of those answers are acceptable. Okay. Notice here, 4 plus 2 doesn't give me 8. It gives me 6, which is not my answer because we are doing a different rule. We're going to have a different property, a different rule for this one. So let's look at the next one. We have 3 to the 4th power raised to the 4th power. So I have parentheses to the 4th power. Write the parentheses out 4 times. And after we do that, we're still not done expanding because we still have exponents. You know you're not done expanding if you still have exponents. So 3 to the 4th means 3 4 times. 3 to the 4th means 3 4 times. 3 to the 4th means 3 4 times. And then, last but not least, 3 to the 4th means 3 4 times. So now I'm done expanding, and now I'm going to count them up. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 threes. That's a lot of threes. So this is 3 to the 16th power, or 43,046,721. Wouldn't expect you to know that off the top of your head. You could type that in the calculator and see that those are equivalent to each other. Okay, let's do one more of these. I have x squared to the 3rd power. Write your parentheses out 3 times. Parentheses to the 3rd power, write the parentheses out 3 times. I still have exponents, so now I need to expand even further. X squared means xx. X squared means xx. And x squared means xx. So I'm done expanding, so now I'm going to count them up. I have 1, 2, 3, 4, 5, 6 x's. So this is x to the 6th power. Okay. Now, let's look here and see if we can see a rule. Here I had 2 to the 4th power to the 2nd power. 4 times 2 is 8. I multiplied my exponent, I got my answer's exponent. 3 to the 4th to the 4th becomes 3 to the 16th. 4 times 4 is 16. We multiplied the exponents and got our answer's exponent. X squared cubed, 2 times 3 is 6. So here it says, when a power or an exponent is raised to another power, keep the base and multiply the exponents. So that means if you have a power raised to another power, notice how there's only one base. A power raised to another power, multiply the powers. Now, this might seem really long and ridiculous that you would write all of this out. I promise you, expanding it is going to be the best way to get the correct answer. Okay, we're going to learn 5 different rules today, and sometimes we get confused when to use which rule. So I really strongly encourage expanding it. Okay, next we're going to do a power of a product property. Notice inside my parentheses, I have 2 bases. I now have my -3 and I have my x. But I have parentheses to the second power, so the same thing we did in the last section, we're going to write our parentheses out twice. Once you do that, you don't have any more exponents, so we're done expanding. So now we're going to multiply our like bases. I have -3 times -3. Those are your coefficients, so just multiply them together like we always have. -3 times -3 is 9. And then how many x's do I have? There's 2 x's, which becomes x squared. Okay, let's look at this next one. I have 3. 3 doesn't have an exponent, so just write it once. Then I have x to the 4th power. Remember, an exponent tells you how many times to write something out. So this is saying I have 4 x's. Write x 4 times. Next, I have parentheses squared. So I'm going to write my parentheses twice. I'm done expanding because now I have no exponents. So now I'm going to rearrange it and make it look nice and neat and combine my like bases. 3 times 2 is 6, times 2 is 12. Then I'm going to count up how many x's I have. 1, 2, 3, 4, 5, 6 total x's, so that becomes x to the 6th power. And there's my answer. The next one, I have parentheses to the 3rd power, so I'm going to write my parentheses out 3 times. X squared y, x squared y, and x squared y. Now I'm not done because I need to get rid of the squares. I need to expand further. So an x squared just means xx. My y doesn't have an exponent, so I'm just leaving it y. Then this I need to write x squared as xx, and then I have my y. And then x squared again becomes xx, and then I have my y. Now we're going to count up, because we're done expanding, we're going to count up how many x's we have. 1, 2, 3, 4, 5, 6. So this becomes x to the 6th power. And then let's count up how many y's we have. 1, 2, 3 y's, so this is y to the 3rd power. And there's my answer. Okay, the next one, I have parentheses to the 3rd power. So I'm going to write my parentheses out 3 times. I'm not done expanding because I still have exponents. So I'm going to rewrite this. The 5 doesn't have an exponent, so 5. I'm going to rewrite this x to the 4th as 4x's. And then my y doesn't have an exponent, so I'm going to leave it as y. And then this one's going to be 5. Again, x to the 4th means I have 4x's. And then y. And then the next one, 5. X to the 4th means I have 4x's. And then y. So now we're going to multiply our coefficients. 5 times 5 is 25, times 5 is 125. And then we're going to count up our x's. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So x to the 12th power. Then we're going to count up our y's, and we have 1, 2, 3 y's. So y to the 3rd power. Ran out of a little bit of room there. Okay, now let's do the last one of these. Here we have a bunch of stuff in the parentheses. We have a -2, we have an x squared, and we have a y cubed. To save us a little bit of room, and as we've now done 4 of these, we might be doing a little bit better, I'm going to expand this and write it 5 times, all in the same step. So I have one -2, because my -2 doesn't have an exponent. I have 2 x's, because I have an x squared. And I have 3 y's because I have a y to the 3rd power, or a y cubed. So my parentheses, these are equivalent. This is simplified form, this is expanded form. Now I have my parentheses raised to the 5th power, so I'm going to write that same exact thing 5 times, so 4 more times. So I have my -2 x, x, y, y, y. -2 x, x, y, y, y. So that's 1, 2, 3, 4. We need one more set of parentheses. -2 x, x, y, y, y. So now we need to combine all of our like bases. -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is 16. 16 times -2 is -32. Then we're going to count up our x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is x to the 10th power. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 y's. So that's y to the 15th power. And there is my answer. So yes, some of them are really long to write out. But again, I promise you, expanding it is going to be the best way to get them correct. Okay, so the rule for this, if a power, to find the power of a product, you raise each factor to the power. So essentially what you're doing is every base in the parentheses is going to be raised to that exponent. You're kind of distributing the exponent to every base in the parentheses. Okay? So those are our multiplication exponent properties. Now we're going to go on to our division exponent properties. The good thing is we're doing the same thing. You're going to expand them. Okay? So this says I have 3 to the 5th power. That means I have 3 5 times. So write it 3 5 times. Over 3 to the 3rd. That means I have 3 3 times. Now, if you remember from elementary school, anytime you divide something by itself, they cancel each other out. So I can look at this as 3 divided by 3. They cancel each other out. 3 divided by 3. They cancel each other out. 3 divided by 3. They cancel each other out. So I'm left with nothing in the denominator, and I'm left with 3 times 3 in the numerator. Since I don't have anything left in the denominator, I don't need a fraction bar. I don't need a denominator. Well, 3 times 3, there's 1, 2 of them, so that could be 3 squared. Or we know 3 squared, or 3 times 3, is 9. Isn't 9 a way simpler way of saying 3 to the 5th divided by 3 to the 3rd? This looks ugly. 9 is a nice, pretty number. Okay, let's do the next one. 3 squared. That just means I have 3 times 3. Over 3 to the 8th. That means I have 1, 2, 3, 4, 5, 6, 7, 8 threes. Okay, you can always cancel out like factors in the numerator and denominator because that's equivalent to saying 1. 3 divided by 3 is 1. 3 divided by 3 is 1, so they cancel each other out. So I'm left with 1, 2, 3, 4, 5, 6 3's in the denominator. Well, with fractions, if you have nothing left in the numerator, you have to put a 1 as a placekeeper. Okay, the reason I'm not going to put 0 up there is what's 3 divided by 3? 1. So I really still have a 1 left in the numerator. Well, 3 to the 6th power is 729. Again, either of those are correct answers. Okay, so those are some with just numbers, okay, or constants. Now we're going to move on to some with variables. So I have a squared. That means A. Then I have B to the 9th power. 1, 2, 3, 4, 5, 6, 7, 8, 9 B's. Divided by it, I have 8 A's. And then I have 4 B's. So again, I'm going to cancel out like factors on top and bottom. I have a set of A's I can cancel. I have a set of A's I can cancel. I can't cancel any more of my A's on the bottom because I ran out of A's on the top. So now I'm going to cancel out B's. I have a pair of B's I can get rid of. B on top, B on bottom, cancel them out, cancel them out, cancel them out. I can't cancel out any more of my B's on top because I don't have any B's left on bottom. So now let's see, I have 1, 2, 3, 4, 5 B's, and my B's are on top, over 1, 2, 3, 4, 5, 6 A's on bottom. Now, anytime we're dealing with fractions, you can't have like bases on top and bottom. So if I still had an A on top, this wouldn't be fully simplified. Or if I still had a B on bottom, this wouldn't be fully simplified. So make sure after you think you got your answer that you go back and double check that there's no like bases or variables on top or bottom. Top and bottom, sorry. So let's do another one with some numbers, but we have more numbers. So 2 to the 3rd means 2 times 2 times 2. 3 squared means 3 times 3. And 5 to the 7th means 1, 2, 3, 4, 5, 6, 7. 7 5s. And then 2 doesn't have an exponent, so I'm just writing once. It has an understood exponent of 1. 3 to the 4th means I have 3 4 times, and then 5 to the 5th means I'm going to write my 5 out 5 times. So I'm going to cancel out my like factors on top and bottom. 2 over 2 cancel. I can't cancel out any more 2's because I only had 1 on bottom. 3 over 3, 3 over 3. I'm done canceling out my 3's because there's no more on top. The 5's cancel a bunch of times. And then I'm done canceling because I only have 5's on top, none on bottom. So I'm left with 2 2's on bottom. I'm left with 2 5's on top. And I'm left with 2 3's on bottom. So that's a good answer, or we can write this as 2 squared is 4, 5 squared is 25, 4 times 25 is 100. So I could write this as 100 over 3 squared is 9. Now, anytime you're dealing with numbers, you want to make sure that it doesn't simplify. Does 100 over 9 simplify? Are there any common factors of 109? Well, the only factors, other than 1, the only factors of 9 are 3 and 9. Which 100 is not divisible by 3 and 100 is not divisible by 9. So we are done. So if you noticed, I had a 5 and a 3 as my exponent. My answer was a 2. I had a 2 and an 8 as an exponent. My answer was a 6. I had a 2 and an 8. The exponent was a 6. A 9 and 4. My exponent was a 5. So hopefully you're noticing that when dividing, thing with the same base. You're going to keep the base, but you're going to subtract the exponents. Okay? Now, if there's more on top, like my exponent in the numerator is bigger than my exponent in the denominator, it's in the numerator, or a whole number. Here, the denominator's exponent is bigger. The numerator is smaller, so it's in the denominator, okay? There's more 3's on bottom, so my answer has the 3's on bottom. Here, there's more A's on bottom, so my A's are on bottom. There's more B's on top, so my B's are on top, okay? So that's one way you can do it. Now we have parentheses raised to an exponent. We kind of already did this whenever we did our multiplying. So I'm going to write my parentheses out 3 times. 3/4 times 3/4 times 3/4. There's nothing alike on top and bottom that I can cancel. 3's and 4's don't have like factors other than 1. So I have 1, 2, 3 3's. So this is 3 to the third over 1, 2, 3 4's. So that's 4 to the third. 3 to the third is 27, and 4 to the third is 64. Either of those are correct answers. Again, since the numerator only has 3's and the denominator only has 4's, I know that 27 over 64 can't simplify. Okay? So again, I have parentheses to the third power. So I'm going to write my parentheses out 3 times. So I have a 2. Then my x, I'm going to write 3 times because it's x to the third power. Over x, I'm only writing once because it doesn't have an exponent, and I'm writing y once. Well, my parentheses are raised to the third power, so I'm going to write this out 3 times. So just like we did up top, we can cross things out that are alike on top and bottom. Here I have an x on top and bottom. They can cancel. X on top and bottom. X on top and bottom. So now nothing else cancels out. So 2 times 2 is 4 times 2 is 8. 1, 2, 3, 4, 5, 6 x's, and they're on top. So x to the 6 on top. And then I have 1, 2, 3 y's, so y to the third on bottom. Again, make sure when you write your answer that there's no like bases on top and bottom. My top has a coefficient in x's, my bottom only has y's. Okay? Let's look at the next one. I'm going to write my parentheses out twice. So I have 6a, b to the third means I have 3 b's. Over 3c squared means I have 2 c's. Write your parentheses out twice. So, there's no like variables on top and bottom. My top has a's and b's, my bottom has c's. My top has a's and b's, my bottom has c's. We can't do anything. However, 6 divided by 3 is 2. 6 divided by 3 is 2. So I can simplify my coefficients. 2 times 2 is 4. And then I have 2 a's, so a squared. I have 1, 2, 3, 4, 5, 6 b's, so I get b to the 6 over 1, 2, 3, 4 c's, so c to the fourth. So my numerator only has a coefficient, a's and b's, and my denominator only has c's. So there's nothing alike in the numerator and denominator that I can cancel out further. We're almost done, guys. Y'all are doing a great job. Okay, I have parentheses to the second power, so I'm writing my parentheses out twice. Now my denominator, I don't have parentheses, so I'm only writing it once, but I'm going to write that t twice. Okay, so now we can cross things out that are alike in the numerator and denominator. Well, I have a -5 in the numerator, -5 in the denominator. I have a v in the numerator, a v in the denominator. I have a t in the numerator, a t in the denominator, a t in the numerator, and a t in the denominator. Okay, so I am left with my -5. That's my only coefficient. And then I have my v. And that's all that was left. Notice there's nothing left in the denominator, so I don't need to have a fraction. There we go. Last one. I have parentheses raised to the 5th power. Write your parentheses out 5 times. And then I have -2 and the 5th power. That means I'm going to write my -2 just once because that the exponent of 5 isn't touching the -2. The exponent of 5 is just touching the n. So I'm going to write the n out 5 times. So we're going to cancel out things. -2 on top, -2 on bottom. They cancel. There's no more -2's on bottom to cancel out with these -2's on top. So let's move on to our n's. Bottom and top, bottom and top, bottom and top, cancel, 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 cancel. So, just like the last one, there's nothing left in the denominator, so I'm not going to have a fraction. I have -2 times -2, which is 4, times -2, which is -8, times -2, which is 16. There's no variables left because all my variables canceled out, so I just get a nice pretty whole number. Okay? So this one's very similar to the power, power of a product property, where if you have parentheses, you distribute that exponent. Same thing here. If you have a quotient, which remember is the answer to a division problem, raised to a power, that's just the quotient of each base raised to that power. So basically you're just distributing that exponent to every base in the parentheses. So yes, there are rules that you can use and apply, but again, I strongly suggest expanding it out because it's a lot easier to see and just count up. Remember, how many times you have something multiplied by itself, that's how you figure out your exponent. I hope y'all have a great day and thank you for joining us.